This is the summary of a paper by Alan M. Turing titled Computing Machinery and Intelligence, published in 1950 in the journal Mind. This seminal paper is widely recognized for introducing the concept of what Turing called the imitation game, now commonly known as the Turing Test, a method for assessing a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Turing begins by questioning, can machines think? And acknowledges the difficulty in defining the terms machine and think. He suggests replacing this question with a more focused and unambiguous one related to a game he describes. In the imitation game, there are three participants: a man, A, a woman, B, and an interrogator, C, who is in a separate room from A and B. The objective of C is to determine which of A or B is the man and which is the woman, based on their answers to questions posed by C. Turing then proposes a variant of this game where a machine takes the place of A, and the question becomes whether the interrogator can distinguish between the machine and the human. He discusses the nature of the problem and the criteria that distinguish between physical and intellectual capacities in humans and machines. He argues that the focus should not be on making machines resemble humans physically, for example in terms of skin texture, but rather on their intellectual capabilities. He then elaborates on the types of machines considered for the game, focusing on digital computers. These computers are designed to carry out operations following fixed rules, much like a human computer would do. Turing explains that a digital computer consists of three parts: a store of information, an executive unit that carries out operations, and a control unit ensuring instructions are followed correctly. Turing categorizes digital computers as discrete-state machines, which operate by moving from one distinct state to another, and he provides examples to explain this concept. In the next section, titled Contrary Views on the Main Question, Turing addresses and counters various objections to the concept of machine intelligence. The theological objection challenges the idea of machines thinking without souls, while fears about machines surpassing human abilities reflect deeper existential concerns. The mathematical objection, based on Gödel's theorem, suggests inherent logical limitations in machines. Turing also confronts the argument about machine consciousness, debating whether machines can truly experience emotions or thoughts. He discusses the skepticism regarding machines' ability to exhibit diverse, human-like behaviors, create original content, and respond to unanticipated situations. Lady Lovelace's objection argues that machines can only execute tasks they are programmed to do, lacking the ability to originate anything. The argument from continuity in the nervous system suggests that the continuous, non-discrete nature of the human nervous system cannot be replicated by machines. Lastly, the argument from informality of behavior posits that human behavior cannot be entirely encapsulated by a set of predefined rules, which machines rely on. Turing systematically refutes these objections, suggesting that these limitations are more about the current state of technology than about fundamental impossibilities, and posits that machines could potentially simulate thinking convincingly. Finally, Turing discusses the concept of learning machines. He suggests that instead of trying to create a program that simulates an adult mind, it might be more feasible to create one that simulates a child's mind and then educates it. This approach could lead to machines capable of learning and evolving, much like humans do through experience and education. Overall, Turing's paper is a foundational work in the field of artificial intelligence, raising fundamental questions about the nature of intelligence, the capabilities of machines, and the possibilities of machine learning.